Hey guys, welcome back. So in this video, we're going to create an implementation of insertion sort. And so if you remember from the conceptual video on insertion sort, we talked about how the goal is to look at the number before or the previous previous number and check if it's higher or lower or greater than that number and keep moving that number along so that you kind of sort it into the right place. And this is constant space complexity because we're not creating any new variables or arrays or anything like that. And the time complexity is n squared because in worst case we have to move every number all the way to the front. Because if we have an example like 6 5, sorry about that. If we have an example like 5 4 3 2 1, we'd have to move our 4 all the way up to the front of the list. We'd have to move our 3 all the way up to the front of the list. And so when we do this, we'd have to compare the 2 to the 5. We'd have to compare it to the 4, have to compare it to the 3, and then we'd put it at the very front over there. And so the same thing goes for the 1. We have to compare the 1 to the 5, the 4, the 3, the 2. And then at that point, we would put the 1 at the beginning of the list since it was less than all of those numbers that we compared with. And so that's like the maximum amount of comparisons that we would need to have. And so that causes that creates the n squared time complexity. And so that is a quick intro to the insertion sort. Let's start implementing it right now. And so what I'm going to do is I'm going to say I want to loop through every number in our list. And so if I go back to 5, 4, 3, 2, 1, what I want to do, I want to start off at the 4 so that I'm in a position to compare my first number. And so that means I need to start off at index 1. And so I'm going to say for I in range, instead of just doing len a, I'm going to do 1 comma len a. And so what this does is we're going to start off at the 1 index, and then we're going to go through all the way till the end of the array, which is, since it's the len a is exclusive, then we're going to go to len a minus 1. And so we're going to loop through all these numbers, and what we want to do is while I is greater than 0, so we want to make sure that what index we're on is greater than 0, because if we get to index 0, it's going to throw an error when we try to compare the number at the 0 index and theoretically the number at the -1 index, but since a number can't exist at the -1 index, it's going to throw an error. And so while I is greater than 0 and I is less than I minus 1. And so what we're doing in this case is if we're, say, looking at say we went through one iteration, we're looking at the 3, we want to check if the 3 is less than the number before it, so the 5. So if this 3 at this index is lower than the number at the previous index, which is 5, then what we want to do, we want to swap those numbers. So we want to say a of I and a of I minus 1, and we want to swap them like that. And then what we want to do, we want to make sure we decrement I so that we keep going backwards in our array. And so this is insertion sort. And so basically what we're doing is if we start at the 4, we compare our 4 with our previous number. So 4 is less than 5, so we switch these. And now if we decrement I, at this point our I was 1. If we decrement I, it's going to be 0, and since 0 is not greater than 0, we're done with that iteration. And now we're going to go on to our next iteration in this for loop, which is going to be the 2. And so the number at our index 2 is 3. 3 is less than 5, so we would flip these around. 3, we decrement I, and so we go from 2 to 1. Now we're at 1, and so now we want to compare the number at index 1, which we swapped, which is now the 3, with the number at index 0, which is a 4. Since 3 is less than 4, we flip these around, and now we have 3, 4, 5. Then we go to the 3, we do a bunch of comparisons. 2 is less than 5, less than 4, less than 3. It goes to the front, and we do the same thing for the 1, and we can see since 1 is less than all those numbers, it's going to go to the front of the array as well. And so we're basically just swapping our number every time till we get to a point where our a of I is greater than the previous number, or our I is basically equal to 0, at which point we just end our while loop. And so what I'm going to do, I imported NumPy, and this just creates a random NumPy array with 15 different numbers between 0 and 50. And so it generates a random array. And so now what I'm going to do, I'm going to run insertion sort, and hopefully when we run it, we get the ordered version of the original array. And so you see we have 48, 43, 44, and so on. And so we have 48, and this whole array is in order 0, 2, 4, 6, 9, 9, all the way to 48. It's in the correct order. And so this shows that we did our insertion correctly. Remember, space complexity is constant and our time complexity is n squared. And that is basically how you do insertion sort in Python. Hopefully this helps you guys, and see you guys in the next one. All right.